Hello everyone, welcome to new class. Today's class is about the solution of system of linear equations, that is non-homogeneous system of linear equations. So let us consider the following system of m linear equations in n unknowns. That is a11 x1 plus a12 x2 plus etc plus a1n xn equal to b1, a21 x1 plus a22 x2 plus etc plus a2n xn equal to b2 etc am1 x1 plus am2 x2 plus etc plus amn xn equal to bn. And in matrix notation, these equations can be put in the form Ax equal to B, where A is equal to matrix A11, A12, etc., A1n, A21, A22, A23, etc., A2n, then etc., AM1, AM2, etc., AMN, and X is equal to matrix X1, X2, etc., Xn, and B is equal to matrix B1, B2, etc., Bn. Then next is augmented matrix. The augmented matrix is denoted like this, that is A is to B. So this is augmented matrix, and it is obtained by augmenting A by the column B. That is augmented matrix A is to B is equal to A11, A12, etc., A1n, then A21, A22, etc., A2n, then etc., AM1, AM2, etc., AMN. Then here we have to put the column matrix B, that is B1, B2, etc., Bn. So this is the augmented matrix AB. So augmented matrix AB is equal to matrix A11, A12, etc., A1n, then A21, A22, etc., A2n, etc., AM1, AM2, etc., AMN. Then here we have to put the column matrix B, that is B1, B2, etc., Bn. Then next is conditions for solution of linear equations. So if row of A, that is the rank of A, is equal to rank of AB, then the system is said to be consistent, otherwise inconsistent. That is, if row of A is not equal to row of AB, that is, if rank of A is not equal to rank of AB, then the system is inconsistent. If rank of A equal to rank of AB, then the system is consistent. And if row of A is equal to row of AB equal to R equal to N, that is N is the number of variables, then the system has a unique solution. And if row of A is equal to row of AB equal to R, which is less than N, then the system has infinitely many solutions in terms of remaining N minus R unknowns which are arbitrary. That is, if N minus R is equal to 1, then the solution is one variable independent solution and let equal to K. If N minus R equal to 2, then solution is two variables independent solution and let variables are equal to K1 and K2 and so on. Then trivial solution. It is a solution where all xi are 0. That is x1, x2, etc., xn equal to 0 in trivial solution. Next is Gaussian elimination method or Gauss elimination method. So these are the steps involving in Gauss elimination method. So first one is write down the augmented matrix AB of the system of linear equations Ax equal to B. Then second one is make suitable row transformations to the augmented matrix AB such that coefficient matrix A becomes upper triangular. So here this A is called coefficient matrix. Then third one is, if a solution is possible, it can be obtained by a process called back substitution. That is, once the matrix is in upper triangular form, then solve for unknowns starting from the last row, which is called the backward substitution. Now let us do the problems related to this Gaussian elimination method to solve the system of linear equations. Test for consistency and solve for the system. 2x1 plus 3x2 plus x3 equal to 9, x1 plus 2x2 plus 3x3 equal to 6, 3x1 plus x2 plus 2x3 equal to 8. So our first step is write the augmented matrix. So augmented matrix AB is equal to, A is 2 3 1 1 2 3 3 1 2, 2 3 1 1 2 3 3 1 2. Then B is 9 6 8. So this is augmented matrix. Now by the row transformations we have to make this augmented matrix upper triangular. That is, we have to make these elements 0. That is, the elements below the main diagonal elements we have to make 0. So for that, here let us interchange these two rows. That is, we have to make this element 1. So R1 interchanged with R2. So here we will get 1, 2, 3, 6, 2, 3, 1, 9, 3, 1, 2, 8. Now here we can make these two elements 0. That is, R2 implies R2 minus 2 times R1 and R3 implies R3 minus 3 times R1. So here we will get 1, 2, 3, 6. Then here 0. Then R2 minus 2 times R1, that is 3 minus 4 minus 1. Then 1 minus 6 minus 5, then 9 minus 12, that is minus 3. Then R3, so here 0, then 1 minus 6, that is minus 5, 2 minus 9, that is minus 7, then 8 minus 18, that is minus 10. Now here we can make this element 0 by doing the operation R3 implies R3 minus 5 times R2, because here both are negative. So R3 minus 5 times R2, that is, here we will get 1, 2, 3, 6, 0, minus 1, minus 5, minus 3, 0, then here it is 0, then minus 7, plus 25, that is 18, then minus 10 plus 15, that is 5. So this is upper triangular matrix, and here we have to check the rank of the matrix A and also the augmented matrix. So here rank of A is equal to the number of non-zero rows, that is 3. Also the rank of AB is equal to number of non-zero rows 3, and the number of unknowns equal to x1, x2, x3, that is 3. So here rank of A is equal to rank of AB equal to the number of unknowns. Hence, the system is consistent. So, the system is consistent and has unique solution. So, the system is consistent and has unique solution. Now, we have to find the solution of these equations. And the solution is by back substitution. So, here from the last row, we have to find the unknown values. That is, this one we can write in the form, that is, this is x1, 2x2, 3x3. So, this can be written in the form, that is x1 plus 2x2 plus 3x3 is equal to 6, then 0, then minus x2 minus 5x3 equal to minus 3, then here both are 0, then 18x3 equal to 5. So, we have to solve from the last row. So, from the last row we can write 18x3 is equal to 5, that is x3 is equal to 5 by 18. So, x3 is equal to 5 by 18. Now, take the second row, that is minus x2 minus 5x3 equal to minus 3. Then put the value of x3 here. Then minus x2 is equal to minus 3 plus 5x3. That is minus 3 plus 5 into 5 by 18. And that is equal to minus 29 divided by 18, that is x2 is equal to 29 divided by 18. So, x2 is 29 divided by 18, then we can take the first equation. So, from the first equation we can write x1 plus 2 into x2. So, x2 is 29 divided by 18 plus 3 into x3 is 5 by 18 equal to 6. So, from this x1 is equal to 35 divided by 18. So, the solutions are x1 is equal to 35 by 18, x2 is equal to 29 divided by 18 and x3 is equal to 5 by 18. So, in this way we are doing the solution of linear equations. Let us do another example. Test for consistency and solve for the system x1 minus x2 plus x3 equal to 0, minus x1 plus x2 minus x3 equal to 0, 10x2 plus 25x3 equal to 90, 20x1 plus 10x2 equal to 80. So, the augmented matrix AB is equal to, here A is 1, minus 1, 1, then minus 1, 1, minus 1, then 0, 10, 25, then 20, 10, 0. Then the B matrix is 0, 0, 90, 80. So, this is the augmented matrix. Now, here we have to make this matrix, that is the coefficient matrix upper triangular, that is we have to make these elements 0. So, for that let us do the operation R2 implies R2 plus R1, then R4 implies R4 minus 20 R1. So, here we will get 1 minus 1, 1, 0, then here 0, then here also 0, 1 minus 1, 0, then 0 here, then 0, 10, 25, 90, then here 20 minus 20, 0, 10 plus 20, 30, then 0 minus 20, minus 20, then here 80 minus 0, that is 80. Now, here this row is 0. So, we can interchange these two rows, that is make this 0 row in the last row. So, we can do the operation R2 interchange with R4. So, R2 is interchanged with R4. Then we will get, so after interchanging we get like this. Now here we have to make this element 0 to make this coefficient matrix upper triangular. So we can do the operation R3 implies. So here R3 implies 3 times R3. So 3 times R3 minus R2. So 3 times R3 minus R2. Then here we will get 0. So here we got like this. That is in the third row 0, 0, 95, then 190. So this is upper triangular matrix. So we can check for the consistency. That is here rank of A is equal to, rank of A is, so this is A matrix. So here rank of A is, the number of non-zero rows here is 1, 2, 3. So rank of A is equal to 3. Then rank of AB, that is augmented matrix, it is also equal to 3 because non-zero rows 1, 2, 3. Then number of unknowns n is equal to x1, x2, x3, that is 3. So here rank of A equal to rank of A, B equal to number of unknowns equal to 3. So this system is consistent and has unique solution. And to solve this equation, we have to start from the last row. So this one we can write like this, that is x1 minus x2 plus x3 equal to 0. Then 0 plus 30x2, then minus 20x3 equal to 80. Then 0 plus 0 plus 95x3 is equal to 190. So starting from the last row we can write 95x3 is equal to 190. So x3 is equal to 190 divided by 95, and that is equal to 2. So x3 is 2. Then second row 30x2 minus 20x3 is equal to 80. So put the value of x3 here, then we will get x2 is equal to 80, then plus 40, that is 120 divided by 30, and that is equal to 4. So x2 is equal to 4 here. Then to get x1, take the first equation. So from the first equation we get x1 minus x2 plus x3 equal to 0. So x1 is equal to 4 minus 2, and that is equal to 2. So here the solution is x1 equal to 2, then x2 equal to 4 and x3 equal to 2. That is x1 equal to 2, x2 equal to 4, then x3 equal to 2. So this is the solution of this given equations. So that is about the Gauss elimination method to solve the system of linear equations. So in the next class, let us do more problems. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.